Hi, everybody. Welcome to the second edition of a virtual QASIG. It's kind of fun. I think everybody is probably a pro at using Zoom meetings now, so you won't wonder about it quite as much. Just to let you know about the format for tonight. One, I'm Jim Frazier. I'm the account rep here at Quardev, and I will kind of get you kicked off, and then I will field questions at the end. So everybody's going to be on mute during the presentation. And then at the end, if you have a question, if you would enter it via the Q&A section, which I'll remind you about again at the end, I will read it in order. If it goes beyond a simple answer and we need to engage with the conversation, unmute you for that. But it depends on what the volume looks like. We're going to try to keep this right at an hour. The presentation is going to be right around 40 to 45 minutes. And then we'll chat a little bit more at the end. So to introduce our speaker tonight is our founder and CEO, Mr. Joe Dillon.
Thank you very much, Jim. Welcome, everybody. And it's my privilege to introduce Rick Martin, who's a software practitioner with a focus on QE and tests. I'm sure you've all read that. And he's going to be sharing a presentation he gave recently on test automation and a summit on Agile Testing, which I really like the idea of Agile Testing, I always have. And I'm particularly interested in his views on CI, CD, CD techniques. So welcome, Rick. Take the show.
Thank you. Let me get everything working here. See if I can make this happen. Oops, what happened there? Hit the wrong one. Okay, let's go up here and go there. I think everybody can see my screen now. Slideshow. Can everybody see it?
No, can't see your screen yet.
Can't see your screen yet.
I can see you.
Oh, well, that's not what I want. I'm not that cute. Let's go back here. Share. Oh, I did it again. I shared the wrong screen.
There we go.
And slideshow from beginning. Okay. Yeah, sorry everybody. You got me in my fancy dress t-shirt. I hope everybody's been safe in this odd COVID era time. It's been really interesting for me personally, working remotely full time, which I haven't done for a number of years. So it's testing our limits of technology and our ability to stay seated in one chair for all day. Anyway, this is a presentation I did a couple months back originally, and it's more of a focus, although it's titled Agile Testing and Test Automation, it is with a focus on why a greenfield platform development project, which is what I'm working on right now, is a little bit different. And so I don't necessarily go into a lot of technical stuff on CI/CD or Agile, but I can certainly talk to that if somebody has questions at the end. Again, I've been doing this for a while. Started off as a developer, and then in the early 90s decided I wanted to go to a startup in Silicon Valley, and took a role as a test engineer, thinking that I would spend a year of my life in purgatory and then move back into real application development at that time. And like I said, that was, what, 30 years ago almost now. So worked in several startups as well as some large companies. I was director of testing QA at Walmart.com, held a contract position very similar to that at Target.com and Walgreens.com. And now I'm a senior SDEC consultant, QE consultant with Unified Consulting that's based out of Kirkland. So testing greenfield platform projects is a lot like trying to solve a maze. you start off, you think you know where you're going, and you soon find out that what looks like a direct route isn't really a direct route. And you've got to be ready to backtrack, change direction very quickly, do a lot of red-green refactor, be ready to do a lot of POCs. We have probably done 5 or 6 POCs in the last 4 months at my current engagement, and some of those have turned into real projects, and some of them haven't. So I think that's a hard thing for a lot of people to realize, that in a greenfield environment, you are probably going to end up throwing a lot of what seems like throwing a lot of work away, but it's actually learning and fine-tuning your expectations and figuring out what will work for what you are eventually trying to get to. The other thing about platforms, it's different. When a lot of people talk about automation these days, they gravitate towards UI automation. Platforms generally have no UI, or very minimal UI, configuration UIs and things like that. So there's not a whole lot of that. This is the sort of work that we're doing, and our current engagement is very much hands-on C# automation, some RESTful APIs, but a lot of just down and dirty hardcore test automation. So no UIs. The other thing is your data may not exist. You may not have access to any real data at all, or you may have access to very limited data sets. So you've got to be thinking about that as you lay out the groundwork for your test strategy. You may not even have the canonical data schema. Ours has changed a couple of times in the last 5 months that I've been with the program. It's continuing to evolve. It'll, as they go through this first major iteration of the project, we'll see it evolve again. So like I said, be ready to change. Data stores may be provisional. And what I mean by that is, you may be used to writing to an existing database, but in our world, you may have a Cosmos DB out in Azure Cloud that is eventually going to be replaced with a MongoDB, but it has to go through the steps of being provisioned at the company. And so you start off with one, but you've got to be ready to pivot to the eventual solution. Oops, wrong direction. Test strategy is interesting when you start to look at a platform. A lot of us think about test strategy and we gravitate by nature to a functional view of the world, where you have unit and code level integration and component and all these other things that are really focused on the functionality of the application. But when you're talking about platform, you've also got to immediately start thinking about load and stress and fault tolerance. This is a platform that needs to be highly available. It has to handle millions of transactions all the time, and so you've got to start thinking about the non-functional side of things very early on. Additionally, you've got to think about your test governance. This is the sort of stuff that we do all the time. How do we generate test data? What's the reporting look like? How do we manage our test plans? All that stuff that we normally do. It doesn't change with a platform. Then you have to layer on security. Oftentimes when you're just working on an application, the security's pretty much been handled. I mean, you have to do maybe some basic auth and authentication and authorization type testing, but typically that's already in place by the time you start working on your testing for an application. But when you're working on the platform, that has to be built in. And finally, you got to look at your data governance, because in the particular engagement that I'm in right now, which happens to be with a healthcare insurance provider, There's a lot of PII that's involved. There's, more importantly, data quality. In this particular program that I'm on, the company, our client, has aggregated several different companies over the years. So there are somewhere around 150 to 200 different applications that all have their own different data schemas. And so understanding the data quality as you ingest that data and it goes on the egress side of things, it becomes an important part of the test strategy. And it just adds another layer of complexity when you start thinking about these things. The other recommendation that we're helping our client with is transforming to a more agile practice, whether it's XP or Scrum or Kanban or some hybrid thereof. Most of the Scrum teams that are on this program are practicing Scrum. One team that I'm working with is more of a Kanban style, but the whole mindset around agility, it's less about, you know, what style of XP or I should say agile that you're practicing, but more that you are agile, that you can address the change that will come, because believe me, it will come. The minute you finish, you know, your first iteration on something, new requirements are going to hit that have been uncovered. A new client or a new client application may be onboarded that has to have a different, slightly different set of requirements. And so we make a really hard effort to get our stories down to 1 or 2 days at most. We typically run in 2-week sprints for those teams that are doing Scrum. So it's, you know, you're trying to get 2-day stories, tasks that are less than half of a day or a day at most. Once you start getting into a day, it's almost a story size. The other thing that's interesting about the platform development is this whole notion of infrastructure as code. Now, our implementation is a hybrid application that part of it's in the Azure cloud, public cloud, and part of it's in the private cloud. And being able to manage that really requires you to start thinking of your infrastructure in the same way that you think about your code. You need to be ready to make changes and roll them out very quickly. You know, gone are the days when I started, and at the first of every financial year, you said, well, I need $350,000 to buy a big Sun Microsystem server, and that'll last me through next year. Well, in the cloud space, you just deploy more services out there and consume more of the cloud bandwidth, and you're done. So it does mean that you have to treat your infrastructure a little bit different. We have implemented what we call both DVT and RVTs. A DVT is a deployment verification test, but an RVT is something that was at least kind of new to me. Others may have heard of it, and it's more prevalent in the world of cloud deployments, where you're actually verifying that the resource is there, not even before you deploy the code itself. Do I have the databases? Do I have the Kafka messaging bus out there, or RabbitMQ, or whatever you're using? And to make sure that those things are in existence before you even deploy the code is really important. Also, early on, think about having production heartbeat synthetics so you can monitor your system. We've been spending a lot of time with figuring out how to monitor this environment, this set of Flex environments that we're rolling out, to make sure that we're maintaining high availability and reliability to our client base. So CI/CD is the big thing that, you know, I don't even know how it's been in existence anymore. I've been on the edges of it or deep into it for at least 10 years now. Um, and it really just you think about testing. At least it has for me. I want to caution people that there is an old saying that don't let the perfect me of the good. And that is very true in a CI/CD CD environment. Now, when I duplicate the CD, I do distinguish between delivery and deployment. In the delivery part of it, it means that our code can be deployed. It is in a deployable state. We run through the integration and it's ready to go at some point in time. In some world, you go straight to CD, continuous deployment. I know at a previous company we had many services that were moving in direction. With this current engagement, because it is a financial engagement and has regulatory constraints, there's always going to be a human decision of when to actually flip the switch and deploy a new version of code. It has to go through its own separate security audit and a couple of other steps before it actually can be deployed and turned on in the real world. But the idea is to have all that process automated, so it is literally just a flip of a button on a console for a DevOps engineer to manage. Everybody's pretty much seen this. So in a CI environment, you basically build the code, run the unit tests. If the unit tests pass, you deploy it to a test environment. You might have several levels of test environments that have different varying or growing levels of data or capabilities. So in the early stages, you may not have all the data that you want for, say, a performance test or a stress test. You'll have just enough to do your functional testing. In the next environment, you may have access to external resources that aren't part of the initial lower environment, test environment where you end up mocking things out. But the idea is to make, from the time that the pull request is made and approved in our pipelines, there is no manual intervention to promote it up the chain as long as the tests are passing and the gates are quality gates are met, which include not only the automated testing, it'll include things like static analysis for standards and complexity and code coverage and all those sort of softer, non-functional type test quality criteria. Oops, I went the wrong way again. Sorry about that. Agile testing in CD. One of the things that people who work with me probably get tired of hearing is I use the term shift left a lot. And what I mean by shift left is don't think so much in terms of the old style of this is a unit test, this is a functional test, this is an integration test. Think more in terms of how soon in the pipeline can you reasonably execute that test case. If you can execute an integration test in a few minutes, push it as far upstream as possible. Make that feedback loop to the developer as short as possible. If you wait because, oh, we only do integration tests in the second test environment, you've wasted precious time. So, you know, you want to move everything as close to development as possible. Now there are things that'll prevent you from doing that. So obviously you don't want a developer to wait, 20 minutes to make sure that his submission passes and gets deployed. So you want to make those first set of feedback tests very quick. And you can do that by setting up different test runs in your pipeline. You might have tests that run with every commit, tests that run a couple of times a day, tests that run only once a day. You may even have tests that only run once a week for like a longevity, reliability type test that you want to really stress the system out over a 48-hour or 24-hour time frame, whatever it is. But the the notion of moving things as close to the developer as possible is a really key factor in my way of thinking. Again, think less about what kind of test, whether it's a unit or a functional test, and think about when is the most optimal time that I can run that test and provide feedback to the team that's working on it. We require two-person integrity on all code, including our automated test code. So by that I mean that you can't just submit your code and have it go. Somebody else has to take a look at it, desk check it basically, make sure that it meets the standards as well as the functional requirements that are given for that feature. Maintain traceability. Every one of our tests traces back to our requirements in Azure DevOps, our test management system that we use. I should clarify that. Every functional and above test. So if it's a functional test or an integration test or a performance stress test or an end-to-end test, those are all linked up to a test case that is written and managed in Azure DevOps. Unit tests and lower level tests that are developer focused are not. They're treated separately, although we do measure the coverage on the unit tests and require a certain level of coverage in order to be to progress through the pipeline. We stress very much using good software development practices within our test code. So if you're not familiar with it, I suggest you all take time to research the acronym of SOLID. Let's see if I can remember it. It's single method, single responsibility, open closed principle. The Liskov substitution principle is the L. I always mix up what the I and the D mean. One of them is data dependencies. The other one may be inverted data dependencies. I can't remember off the top of my head. Sorry about that. But I recommend that you go look at it and think about how that applies to software testing. A lot of times we don't spend near enough energy making sure our test code is at the level of our application code or approximately at that level. Obviously, you're not going to invest as much time in your test code as you would in your application code. But you really need to think of your test code as a corporate asset. The company is paying good money for you to develop automation, and that automation is supposed to provide an ROI. And the only way to really realize that ROI over time is to make that good, solid code that is extensible and maintainable in the future. If you just do a half-baked job of writing your test code and it's spaghetti and the requirements change and you spend 2 weeks teasing out different pieces of your code to figure out how to build new tests for the new requirements, you're not doing yourself or your company any favors. So take the time, make the code good, make sure it meets reasonable standards of quality implementation. The other thing that we stress a lot in our engagement is we're not really parochial on who implements a test. What I mean to say by that is, tests can be developed by an SDET, they can be developed by a developer, an app developer. There have been instances in my career where, because we use a Gherkin style of test development and we develop a nice DSL, that literally halfway through the program, a product owner can write a test because he knows what the different phrases are, what the SDL is for that area of code. And they can literally put the test case directly into the requirements, the story, the story in wherever you're tracking your project. So, if you get to the level of where your where your product owner can literally define the test cases just by using an SDL that you've defined for them, you're going to save a lot of time, and they'll get to where they're developing even better requirements and user stories for you. Another thing, don't ignore failing tests. Failing tests are a smell, even if you know, yeah, we got this failing test, we know why it fails, it just doesn't rise to the level of priority. Whenever you ignore a failing test, you're diminishing the value of all your testing, because people begin to see red as just another shade of green. And that's obviously not what you want. Passing tests need to be passing, failing tests need to be failed. And if they're failing, you need to either fix them or remove them from your test plan. Now, like I said, you can develop tests that are ahead of the application development, and we do that all the time. So we will develop our test plans and implement our test cases even before the application, has really come into fruition, and the pipelines will fail constantly until the developers catch up with the testing. And that's actually a really good thing, because it gives everybody a little bit of endorphin rush, and then they start to see things go from red to green. It's a huge boost for everybody, and it gives you the best indication of how you're making progress, better than any burn down chart or anything like that. It's like, we defined 100 tests, we've implemented 80 of them, 60 of them are passing today. Tomorrow, 70 of them will be passed, and we'll have the other 20 tests implemented. So those are good metrics to keep in mind as you're going through a greenfield development, because it really does give everybody a nice, tangible touchstone about where you are, not only from a quality aspect, but from a product development aspect. The other, I got a little asterisk here, don't make exceptions to the process. And everybody makes exceptions to the process. That's why there's an asterisk there. We made exceptions to the process early on as we got a little bit more confidence in the approach and strategy that we were using and the technologies that we were basing our development on. We've tightened that down, but there will always be exceptions to the process. Your job as an SDET is to make sure that people understand you're making an exception, and here's the risk that is being brought to the program because of that exception. It's not to say absolutely we cannot move this milestone or anything else. Our job is not to prevent software from going out. Our job is to make sure that software going out is of sufficient quality that we're not going to let our clients or our customers down. So don't be afraid to make exceptions when there's a good business requirement for it, but hold people's feet to the fire when they make it. I think everybody has seen the testing pyramid before. I like turning it upside down. This isn't new. I plagiarized this from, I'm not sure who, might have been Crispin or one of those, Merrick, I don't know. Anyway, the idea of inverting the pyramid and standing it on its point is, think of it as a big funnel for bugs. And your unit test should be catching most of the bugs before they get to the next level of testing. We'll call it functional for now. And that should, excuse me, the next level should be a little narrower, not quite as many tests involved, but they should be a little deeper in what they cover, and they should catch a more difficult or complex level of defect. Then you get to the integration test and the system test, and finally UAT, or manual UI testing. And you want those to be as light and as thin as possible by having this development of tests your test pyramid where you really foundationally are focusing on catching things at the unit level and the first level of functional tests, which I call functional here, but the whole idea is to catch bugs early as much as possible. What I found in a lot of companies where there are a well-established test development and automation team is you get an inversion of between your functional and your unit tests. You may have, 100 unit tests, but you'll have 250 functional tests. Well, typically the functional tests require real resources, or at least some real resources, whereas your unit tests, at least in our implementation, are all in memory. So all the external resources have been mocked out, data's mocked, all that sort of stuff. So a developer has no reason not to execute those unit tests on his local machine. And we want to make sure that the coverage that he gets at that unit level is as high as possible, given that he's having to mock resources and data out. So we already have, as I said, we've got a couple of teams that are struggling with this because the developers are jamming to get their tests, their applications written. And meanwhile, we've got SDETs that are busy writing tests. And again, it's going back to, you think back to what I said earlier about shifting left. If you can take a functional test and convert it to a unit test where things are mocked and it can be run locally, not only is it faster, it'll be run more often and more consistently as part of the build process. And that's just improves the feedback loop that you have for your developer. We talk about not best practices, but gooder practices. It's kind of a running joke within the teams that we have at my current client, because a best practice is what works best for the team. And that depends on your market that you're in, the technologies you're using, the skill sets you have on your team, the maturity of your product. All these things go into it. You can take a very seasoned, mature project with a seasoned team working on it, and the same sort of requirements and overhead that I'm going to put on them is not what I'm going to put on a team that's running a greenfield. We've never done this before. Our team has one senior person on it and 5 junior developers and maybe one good seasoned SDET and a bunch of junior test automation engineers working with it, or QA people working with it. So it's not the best practice, it's the gooder practices that, given the environment that you're working in. Our current tooling, we use Visual Studio 2019, ReSharper and NCrunch. If you're not familiar with those, ReSharper is just a nice add-on to Visual Studio that makes refactoring code a joy, actually. NCrunch is a background test runner, so if particularly useful for unit testing. If you turn on NCrunch, and as you make changes to your code, it automatically runs your unit tests for you and gives you real-time feedback. Again, like I said, anything that we can do to shorten the feedback between the developer and the test execution, the better off we feel we are. For test frameworks, we use XUnit with fluent assertions and mock for unit testing. A little bit of Postman, a little bit of Swagger pages thrown in just to keep things interesting. But for the most part, as I said, we're writing C# code. We have no manual testers on my current engagement. Eventually, as we start adding real clients, real external clients to our platform, there will be manual testing. That's just par for the course. But as we're building up the core applications and the platform itself, everything that we can automate we do. Not to say we don't do any manual testing here and there, just because there are some tests that don't make sense to automate, no matter how simple it is. Either you know that that feature is going to go away in the future because you're moving to a different technology, or it's a one-time test that, hey, yeah, we got to make sure this ARM template works correctly. We'll do a first-time test on it, but we're not going to test it every time it's deployed. We use static scanners, SonarQube. If you haven't used SonarQube, it's something you should look into. I have a lot of great experience using static analysis to help drive quality. You can head off a lot of things. You know, in the old days, we used to go through and you know, you'd have the arguments over, does the curly brace belong on the same line or a separate line, or however it is. You can make that automatic through a scanner like SonarQube. You can also set up different other layers of criteria, or different other criteria such as code coverage, or you know, I've even seen some teams have a golden ratio of comments to code, or to-dos, how many to-dos are in their code, as things that they flag through static analysis. So that's something I would suggest if you haven't ever used it before. SonarQube is an open source tool. It's a little bit onerous to get used to it and train it for what you want. It has some built-in rules for different languages, but I've never been with any company that didn't tweak those rules to meet their needs. Containers, VMs, and hybrid cloud. What can I say about those that you don't probably already know? Containers is a huge thing. I think at least in the last half a dozen years, almost all of our development and testing has been focused on either a Docker container or AKS or PKS or some other form of container that I haven't heard of. But it makes it really nice if you can just pull down an image and have your environment set up, and you know that it's a standard configuration and that everybody's using the same environment. And it kind of gets away from the, well, it works on my machine, if you're all using a standard image for your execution environment. Let's see, non-functional testing. In larger enterprises, a lot of times they'll have a separate security and or performance team. That doesn't relieve our requirements to do some of that testing as soon as we can. We should be developing code that meets minimal standards for performance. And if you're developing a service and part of the requirements for that service doesn't talk about the SLA, then you should reject that story and get the product owner to give you an SLA to target. If you don't, they're going to come back to you at some point in time and say, it has to scale more, it has to be faster, whatever the metric that they're looking for. So I think it's really important to get SLAs up front, particularly for services. And I think that it will inform development and the way you go about testing your code if you have those SLAs to look back on and say, well, are we meeting the SLA? Are we close? Or are we so far ahead of the SLA that we're not going to worry about it right now? I can tell you a recent example. We were implementing a messaging bus, and we asked the product owner for an SLA, and he says, well, 1,000 messages a minute. And I said, fine, okay. Well, we got, I think, somewhere around 6,000 messages, not a minute, a second. We got around 6,000 messages a second. And they were like, oh, okay, well, we didn't think we'd get that till version 2, but great. So get those SLAs and code in a way that you keep those in the back of your mind. You may even go to the point of putting in your performance testing as part of early on in your pipeline, but not fail the build because it doesn't pass performance, at least in the early stages, but at least you see a trend and you can follow that trend and say, are we getting better? Are we getting worse? Is it staying the same? Is it going to be good enough, do we think? And just having that information early on is very useful. Events, telemetry, profiling, logging, particularly for a platform, these are things we've been putting in early on. In fact, I've spent probably out of the last 6 months, 4 months of that focusing on telemetry and eventing at my current engagement. Very important for the company to understand how the system is performing and how workflows are progressing through the system. Incorporate first order security into your static code analysis. So what I mean by that is, you may not have a whole lot of security requirements early on, but there are some basic, the OWASP 10, for instance, I think it's 10. You can build that into SonarQube. It'll run them for free for you, well, relatively for free. And so you can get an idea of, are we at least keeping the risk, the security risk, in a reasonable state, even before we go to pen testing, get to the point where we can do pen testing and have the security audits that are required by a lot of major corporations these days. How am I doing on time? Yeah, just about ready to wrap up. Test governance, again, as you're building out things, you want to make sure that you're reporting on your testing, you're keeping your leadership informed of what's going on. You've got traceability from your test cases back to the features or the stories. In our environment, like I said, we don't do a whole lot of manual testing. So, but when we do manual testings, those are pretty much detailed out every minutia of the test case. The idea being that, it could be that this week you're executing the test case, but next week it could be someone who's not even in your locale, and you want them to not have any questions about how that test is operated. For automated tests, we do more of a tombstone style test entry, and by tombstone, I basically mean a title and the high level. Here are the inputs that are required. Here's the expected outputs. Not much more than that, because you're going to automate that. All of our tests follow the HOR triple. It's basically arrange, act, assert. So you do a setup, some event happens, and you assert that the results are as expected. Our tests are also single focused. So we don't have an assert that, for instance, let's say you had a transaction that has to update 2 different tables. We don't have that test, a single test that does the assertion on both of those tables. We build separate tests for that. And the reason is, when that test fails, you want to know exactly what's failing and why, and not have to do any sort of debugging on it beyond the normal, how do I fix this problem? You don't want to waste any time figuring out what the problem is. The extra time and code that'll cost you, you'll make up for in the long run if you have single focus for your tests. Each story has vetted acceptance criteria. As I said, we are pushing and getting more and more of our product owners to develop in a Gherkin style. If you've done any sort of tests with Cucumber or JBehave or something like that, you're probably used to the Gherkin style, where you have given, when, and then in your tests. So if you were to look at some of the tests that we write, the test cases themselves may only have half a dozen lines of code, and they are method calls that are predicated with the given, when, then. And then the details are abstracted out into those lower methods. There's 2 reasons for that. One is it makes your test case very deliberative and declarative. You know exactly what's going on. Given I have this REST request, and given I have this database set up, when I make a commit, or do some transaction, then I can assert that this table has changed in a specific way, or a signal has been sent, or telemetry or logging, whatever it is. You want to make sure that you don't have to know the underlying implementation of the test in order for the test to be intuited by someone who may not have that depth of knowledge. Particularly, let's be honest, not all of our product owners are hardcore techies, but they do know the use case. And if you can develop that that language with them, so that they understand that when you make this phrase, when you use this phrase, this is exactly what it means, then you're both going to be out ahead. There will be no ambiguity between you as to what they're asking for and what you're delivering. Let's see, I think test data management. This is a biggie for most companies. As more and more our code is moving around data more than anything else. It's aggregating data, it's teasing data apart. So managing that data, understanding how to create data on the fly, or whether you have a golden set of data that you refresh on a regular basis, however you want to do it, you need to spend some time up front making sure that you've got a good strategy in place. We deal with terabytes of data these days. I can't think of any application I've worked on in the last 10 years that hasn't had millions and millions and millions of rows of data involved in it. So it's something you need to be careful about and think about early on in your test strategy. You need to be realistic about it. The company's not going to pay for you to have all the data that you want. You need to get enough data to do your job, and if you can get more, fine, to give yourself buffer, but be realistic about what your needs are. The data needs to be consistent. You need to keep, whether you refresh it from a sanitized version of prod or however you migrate your data, be consistent with how that happens, so you know from one run to another that your data is not the problem. Also, as always, you've got to worry about PII and security issues around personal identification. And here's one thing, I put this slide in after I gave this talk the first time, because it just so happened that the week afterwards, we had a really serious issue. Somebody made one innocuous change to a ARM template, I believe, and it basically disabled our development environments for the better part of a day. So never waste a disaster. You either win or you learn is a phrase that I've seen, and I love that phrase. So it may not feel like you're winning right now, but if you learn from it, you've won something. So when disaster does strike, and it will, identify the gaps, document the findings, build a playbook around it. Make sure that that same disaster can never happen again. And I think a lot of teams, they'll deal with a disaster in the heat of the moment, and they won't document anything. They won't go back and figure out, well, how do we make sure this doesn't happen now? Most teams are good enough about building a test case around the problem, but really take the time to understand what the real source of that problem was and get it documented and get it communicated and socialized so that other people learn from your mistakes. We don't, as I said, we don't want to waste a disaster. And that's it. I'm Rick Martin at Unified Consulting. Personal email, rick@bearblue.com. And my LinkedIn address is pretty simple as well. So I guess questions now?
Yeah, thank you very much, Rick. And for those out there in the field, if you can enter your questions on the Q&A portion, that's a great way to go. Our first one of the evening is from Christian Vaughn, who says, have you encountered any pushback when moving tests from manual to automated, i.e. vendors and some staffers concerned about jobs being eliminated? And if so, how did you navigate those challenges?
So yeah, obviously it's disruptive, right? As you start moving to a more automated focus of your testing, it requires a different skill set. It's more money up front, and that's usually the resistance you get from the vendor. But I think the onus on us is to show what that payback is over the long run. And there's tons of data out there that make all sorts of claims, whether it's 4x or 10x or whatever over the course of the project. The reality is, I was reminded the other day of a great quote from Boris Beezer, if anybody remembers him, way back. I think this came out in the 90s. But he basically was saying, it's not just about writing the tests, it's the whole process of developing automated tests take you to another level of thinking about your application. And it really does drive and inform the design and the implementation around that. For one case in point, when you think about mocking things out, well, that automatically pushes you to using interfaces, which means maintainability, and the Liskov's principle is supported, that you can interchange things at a later date. So I think that from the vendor perspective, you need to make sure that they understand what the full benefit of doing test automation is, not just the, oh, I write it once and I can run it 10 million times for pennies, because that really doesn't really return the investment that they're thinking about making. On the other side of things, the personal resistance, because some of your QA people may or may not have the skill sets, and that's something that you can invest in. There are some people that will make that transition, and to be honest, there are some people that won't, and that's just a fact of life. And you've got to be honest with them and say, listen, this is the direction we're going. We will support you in making that transition. If you decide you either can't or don't want to make that transition, we'll help you in other ways by helping you find another role within the company or outside the company if it comes to that. And I've had those discussions with people on my team in the past. More than likely, it's been my experience overwhelmingly that they'll want to try and make that transition. And so you've got to be ready to support those that are willing to invest in themselves and help them get on board. Now, you can start off with things that are a little easier to understand as far as automation, doing a Selenium with a Cucumber front end to it or something like that, where you can actually, it's a nice introduction into automation. It can be, you can leave the really hardcore stuff to the really technical SDETs and let the people that are transitioning from manual to automated work on the front end of that process. So I think there are things you can do, but there will be some people that just either cannot make that or don't want to make that transition, and you've got to be ready to just deal with that in an objective and humane manner.
Great, thanks, Rick. And Christian, if you had any follow-up questions on that, please feel free to email those in and we can forward those along.
And so what I've found, just to ease the anxiety of anybody who's asked, because this question's come up a couple of times during this talk. What I've found over the last 25 years of being in this business is that automation testing actually leads to more manual testing, because you have to test the automation test. And automation testing comes in handy for a lot of things, and puts the accelerator on the basics, but everything still has to be touched, and it has to be used. And so it's actually kind of a win-win situation to have automation testing. It's a separate set of code. It
Mhm.
needs to still be tested. So it has to be done.
Well, and the other part of that is every automated test starts off as a manual test.
Right.
I mean,
I know.
even if, even if you're starting out immediately implementing code, you're manually going through that process and maybe trying things out as you're writing code to say, hey, what happens if I do this? Or what happens if this input is tweaked in a certain manner? So they do go hand in hand.
Yeah.
I
It's
think
not one of those things that's going to eliminate jobs. It's one of those things that's going to, just create more.
Yeah.
Go ahead.
So Jim, were there a couple more questions?
We do have a couple more. I know we're coming up at the end of our hour, but I think we can probably buzz through these relatively quickly. An anonymous attendee who asks, how do you suggest a new developer put these concepts into action, especially in between jobs?
Well, the first thing I think, and this is a challenge for just about everybody, is our industry moves very quickly. And I'm continually having to take time out, whether it's in between gigs or on my own time, to learn something new. I had never, to be honest with you, before I started this engagement, I'd never done a whole lot of work in the .NET world. I'd always been a Linux, Java, Ruby type developer. And so I had to take a lot of time early on when I first got started and put in some extra hours and learn C# and .NET and how all that fits together. So working on your technical skills is the biggest thing I can suggest. If you can find it, if you're in between jobs or in between gigs and you can find an open source project to contribute to, even better, because it's great to be able to put that on your resume, to be honest with you.
Okay. I have another one for you, Rick, and this one's from Dwayne, who asks, for those of us who are new to CI/CD, what's a good CI/CD technology to learn?
I started off with Jenkins, again, because it's open source and Java, so the price was right. I think that there's several tools out there that now have the freemium type model where you can get some basic exposure to it until you get to a certain level. I'm not sure if Azure has that, but I think there's Circle CI, I think, has something along those lines. Amazon, I think, has something along those lines. So there are open source or open commercial tools, I guess, freemium type things where you get a little bit of taste of it. You can use it enough to develop your skills, and then continue on from there. The whole concept is really straightforward, right? You're just trying to automate the quality gates that we used to implement manually. So it's fairly straightforward. It's not as scary as it sounds. There's different ways of implementing it depending on what technology stack you're using.
Okay, I've got another one for you. This one from Josh Chin, who asks, what do you think of an SDET's role in infrastructure? In most places, you'll have a DevOps team for CI/CD, and you either hand off to them or work them to integrate automation in the build infrastructure. Do you have most SDETs needing skills in DevOps tools, i.e. Docker?
Well, I believe that, first of all, I believe that you're never going to hurt yourself by learning something that doesn't necessarily fall squarely in your skill set. So, for instance, I run Docker on a server at home here that I try things out on, mostly because I don't want to pollute my server. When I'm done learning something, I want to throw that image away and be done with it. So it's good from that perspective. But we have an interesting, so the team that I was on had SDETs, it had application developers, and for the first 5 months, it had the DevOps team was part of it. Now the DevOps has grown to an extent where they've split off into their own team, and they're becoming, cross Scrum team supportive in their efforts. but we still work with them on a day-to-day basis of, okay, you know, as you roll out containers, how are we going to build our VT tests? What is that? How does that impact our testing? How are we going to ensure logging comes out of there properly? All those sort of things. So I do believe there are opportunities for SDETs in a DevOps team. They may be a little bit different, and the focus is going to be different than what you get if you were testing an application, but it's still there. The mindset of a tester doesn't really change. You're just looking at what the specifics of what you're trying to validate are, and you're still looking at it with that testing mindset of, okay, this is what you tell me it's going to do. What happens if?
Okay, and I have one last for you. Sorry, Cindy, I'm going backwards here, but Cindy is wondering, do you keep the same approach to testing once a prototype goes live in the market?
Do we keep the same approach to testing? Yeah, because I've never seen a project yet that once it goes live stops evolving. You're continuing to add features, fix issues, work on scalability, whatever aspect of that product is. Products just don't get released once. They get released many, many times. And in fact, I was at a company not too long ago where it was relatively a mature product, but we were still releasing on a monthly basis. And sometimes it was just bug fixes, but oftentimes it was bug fixes and small features, or occasionally a big feature would come along. But those products, those software products by very nature continue to evolve and continue to need testing and new testing, and the testing that you wrote last year doesn't quite work anymore. And you know, I go back to, you don't write the test once and walk away from it just because it's automated. It gets maintained just like any other piece of code. And so in my mind, the approach doesn't change that much.
And we're starting to go over. If anybody has any further questions, please feel free to email them in, and we will forward them over to Rick and make sure that they get answered. But we're just a little bit over our hour, so I think we'll wrap here. Joe, did you want to finish up?
Sure. I just had a couple of comments. Great talk, Rick. Really, really good. I really like the idea of agile testing and everything else that you're doing. And I liked the comment that you made about sufficient quality. And it reminded me of both Jim and John and James Bach used to work at Quardev, and they have this term called good enough.
Yep.
And I think that those are misunderstood terms. Sufficient quality doesn't mean, it's okay. And good enough software doesn't mean, it's good enough. It means it's good enough, and it's sufficient, and it matters. And that's what we're all in this business about, is to make sure that things don't break.
Yeah.
And I also liked your idea of catching bugs early, you know, and agile testing. That's what it's all about, catching them early, saving money.
Yeah, the thing that I tell people about the good enough, you know, the level of quality you're going to put in a $2 game that you buy on your phone is going to be a little bit different than if you're working in nuclear medicine. And so you got to know what your market needs and drive to that level. You know, you want to make sure you've got more than minimal quality, but you know, it really does depend on your market.
Yeah. And it has to be a high standard.
Yep.
And that's what you're here for. All of us.
Thank you for
Yeah, thank you. Thank you, Rick. I really appreciate your time and taking your time out of your schedule to talk to the group. And thanks for everybody for joining.
Yep.
Let's keep it
Feel
going.
free
Even
to
though
contact me directly if you have questions. I'm willing to answer them.
Yeah.
All right. Thank you, everybody.
Have a
Thank
good
you,
night.
Rick.
Thank you.
Good night.
Good night.